In this presentation, we're going to look at regression. So essentially what we're interested in first off is the relationship between quantitative variables, okay? Quantitative variables. And in the short term, what we'll be specifically interested in is two quantitative variables. So the first thing we have to do is, my pen is just jamming up here. Let's just check that. The first thing we're going to do is, one, draw a scatter plot. Okay, so let's do that. So suppose this is something I have coming up now. Suppose this is our scatter plot. We plot the x variable down here and the y variable along here. So essentially, if we had a point, let's say 5 and 10, okay, so the point we were interested in is 5 and 10, we would just put it here, okay. So scatter plot. So the x value is 5, the y value is 10. Now what we might be interested in is determining, is there a linear relationship between the two variables? And essentially what we're how we detect that is to sort of see, is there a sort of straight line that sort of indicates the overall trend in the data along the scatter plots, through the points on the scatter plot. So this is a sort of contrary example. So this is an example where it's not linear. There's more curvature in the relationship. Okay, so it's not a straight line at all. You could try a straight line, and it would look something like this, but you just know that it's not right because it just isn't, basically. Okay. So there's other techniques you might try there, but essentially linear regression is not right. So in a case where it was right, all right, we're good to proceed. So the second thing we do is, if the scatter plot indicates an approximately linear relationship, it doesn't have to be perfect essentially. What you could do there is measure the strength and relationship, the direction of the relationship, by calculating this thing called the correlation coefficient. Okay, and we denote that R. Okay, that's how you denote it. Now, actually, when you go on a little bit further, you realize that there's actually more than one type of correlation coefficient. Okay, so this is just for this presentation, is specifically for beginners, but if you go on a little bit more advanced, you will call this a Pearson correlation. Okay, so Pearson correlation, I'll just write up at the top there. There's other types called Spearman and Kendall, but we could save them for another day. So the third step, calculate the equation of a line which best describes the relationship between the two variables. This is called a regression equation, a regression line, or fitted line. Okay, so let's just say, go back to our example here. No, it's not it. It's over here. Oh, this is very slow. Essentially, it's a mathematical formula. There we go. So a mathematical formula, you might have it like something like this: y hat equals. I'll come to the hat business shortly, why that hat is there. But we say y hat equals. I'm just going to make up some data here that's sort of 0.05 plus 1.9. 5x, something like that. That's our regression equation. Okay, and this is essentially will be calculated from the data. Okay, we're going to talk about where that comes from shortly, but this is the end point of a, well, it's not the end point, but it's a sort of big step in a regression analysis, is to construct this regression equation. Okay, so we're going to consider the simplest type of regression line. There's only two variables. We have a predictor variable and a response variable and a predictor variable. The response variable we usually call y, and the predictor variable we usually call x. Now, just as a remark, they're also called the dependent variable and independent variable. And I might use those interchangeably. In fact, I probably will, just to put you on your toes a bit. Okay. Now this is called simple linear regression. That's an important little definition there. Simple linear regression. Essentially, one predictor variable, one response variable. Okay, the mathematical model is as follows. So y hat equals, this is beta 0 plus beta 1, and this is a random error term. It's just to allow for random fluctuations. But essentially, beta 0 plus beta 1x, this is what they call these parameter values are the slope and intercept. Okay, slope, well actually I'll put them in the order they're shown there. Beta 0 is the intercept, and beta 1 is the slope. Okay, now these are what they call parameter values. They're the true values. Okay, I'll just write that up there, but beta 0, beta 1 are the parameter values, and these are the true values of these beta 0 and beta 1 are almost always unknown. So what you do is you try and come up with estimates from sample data. Okay, so that is what we're getting towards here. So the equation that best describes, let's scroll down here. This just jams up and I got too much going on. There we go. It's just too much software running at the same time. The regression equation is that best describes the relationship between x and y is called a regression equation, and it's used in simple linear regression as follows. Okay, so y is the value of the response variable y. Okay, x is the value of the predictor variable x. Beta 0, beta 1 is the slope and intercept, and the random error term, also known, well, it's not really actually the residual. I'll sort of skip that part. It's not actually the residual. It's just a little bit of random error. Okay. Now, essentially, the idea of is we're trying to come up with estimates for beta 0 and beta 1. We don't know what they are, so what we'll do is try and estimate them from data. And as a result of that, we so meaning of the regression coefficients. Beta 1 is the slope of the regression line, okay? And it gives the average change in the response variable y for each unit change in x. And it could be positive or negative depending on the type of relationship between the two variables x and y. So a positive slope of x, for example, means that for every unit increase in x, a positive slope of 5 means, for example, that for every unit increase in x, we expect a 5 unit increase in y. Okay. Now, this is important, this bit. Beta 0 indicates the value of y when x is 0. And it only is really meaningful if populations could have x values of 0. Okay, so that will require some examples to really flesh that concept out. Okay, so anyway, let's go on. I'll just try and get down here. It's really slow. So depending on what data you've sampled or collected, you could draw a straight line through the data. Okay, and there's multiple samples you could take, and there's multiple methods you can take. So we're going to sort of concentrate on one method. This is the usual method in undergraduate statistics. It's called the ordinary least square, or the least square. And it's one of the methods that can be used to find the straightest line between the data that provides the best approximation for the relationship between the variables, the predictor variable and the response variable. Here I call them the independent and dependent variable. Okay. This method consists of choosing estimate values of beta 0 and beta 1, which minimize the sum of the squared vertical distances measured in from each data point to the line. Okay, now that's quite important later on, so I'm just going to sort of bookmark that a bit with this term here, residual. Okay, this is important, but we're going to sort of come back to it later on when I talk about residuals. Okay, so it's a big important step here, but it's best talked about later on. Okay, And what you might do here, just to finish up, is come up with this regression least squares estimate. Okay, so y hat, these are the important things here. The estimate values for the estimated intercept of the line and slope of the line. And we denote these. These are estimates for beta 0, beta 1. So beta 0, the estimated intercept for the line this is an estimate for beta 0, as you can tell. And this is an estimate of the slope beta 1. Okay, and y hat is the estimated value of the response variable y for some given value x. Okay, so let's just actually try that out for a second. Suppose beta 0 was 1, or b0 was 1, and suppose b1 was 4. Let's try this out. So let x equal to 5, and let's compute y hat. Okay, so that is y hat is 1 plus 4 times 5, and that is equal to 21. Okay, now this is what they call a fitted value. Okay, a fitted value for y, or predicted value for y. Okay, now that's what the point of regression is really. Just can you, given a value of x, can you predict y? Okay. Now, one last thing before we go. How to calculate it. So, this is really slow. Okay, that's not working for me. I'll tell you what, I'm just going to leave it there. So the next thing we're going to get onto is how to calculate beta 0, beta 1. That was just a sort of quick introduction to regression, but we're going to get into the nitty-gritty now.